Hello dear students, in this video I'm going to cover up the cross product and its applications. So first thing that I'm going to talk about is what exactly is cross product. So it's another type of multiplying two vectors. There are certain properties which are different from the dot product which I covered in my earlier video. Now what you need to understand is that if I have two vectors, vector A and vector B, what's the whole procedure to find out cross product? Now, before I go to cross product, I want to show you what exactly does it mean. So when you have two vectors, vector A and vector B, and if you're cross multiplying these two vectors, you're going to get the third vector which is going to be perpendicular to both. That's your cross product. Now the procedure is that you're going to write down the ijk, the first vector out here and the second vector out here. Taking an example to evaluate cross product, consider my first vector as -1, -3 and 1, and second vector is 1, 1 and 0. Now what do I do is, a first thing is that write down the vector ijk in the same form out here that I've written. Then here is my first vector, here is second vector. Now to evaluate this, you're going to pick up I, take this I, and once you pick up I, forget about this row and this column numbers and do the same thing for the other ones. So let's say if you take I, it's going to be -3, 1, 1, 0 out here. Then it's generally plus, minus, plus. Then it's going to be -j. If you take j, don't take the numbers below this row, below this column. So the numbers that are left is -1, 1, and 1, 0. So that are going to come out here. Now once you take k, don't take the numbers below this. So what are left is -1, -3, 1 and 1. Now to evaluate this, what you do is, you first multiply -3 into 0, which is 0, minus 1 into 1, so which is going to be -1. So that's how -I. Here again, you multiply -1 into 0, which is 0, minus 1, which is again -1, but because of this minus, it becomes positive j. Similarly, now you take -1 into 1, which is -1, positive 3, so it's going to be positive 2k. So this is the cross product of these two vectors. If you didn't understand the procedure, watch the video again. If you understood, move on for the applications of cross product. Now, as I told you earlier, this is the another definition. Cross product of vector is also, if you know that the cross product of two vectors is another vector. So what I'm going to do is, this is the other way you can find out the cross product value. So A cross B, the magnitude of that, remember that magnitude, not A cross B, is equals to magnitude of A, magnitude of B into sine theta. Got it? Now, other property is that A cross B is perpendicular to A. A cross B is also perpendicular to B. So A cross A is 0 because you're taking the cross product of the same vector with itself. So it's going to be 0. So I cross I, J cross J, K cross K, all are going to be 0. Now, coming to one of the applications, generally this question is assessed several times in the IB examination. So this question is kind of going to help you figure out the property, apply this property out here. So let us say if they prove that, if they want us to prove that A cross B, the whole square is magnitude of A square, magnitude of B square minus A dot B the whole square. So first what you do is, A cross B is magnitude of A square, magnitude of B square, sine square theta. You can just square this result and you're going to get the same thing what I'm talking about. So that's going to be magnitude of A square, magnitude of B square, sine square theta. In place of sine square theta, I can just put 1 minus cos square theta. Now, this is going to be, open up this as 1 minus cos square theta, expand it, you're going to get this. Now, first term I'm maintaining as it is, and if you look at this term, which is nothing but A dot B the whole square, it is A dot B the whole square actually, if you see, because that's magnitude of A, magnitude of B cos theta the whole square. So that's it. So hope this particular concept you understood. In case if you haven't understood, like, you may try this on your own or you can just watch the video again. Moving to the next application of the cross product, that's your finding the area of a triangle. Alright, generally what happens is that in IB exam, you are given three coordinates and you want to find out the area of this given triangle. So what you do is, out here, first you find out vector AB, uh, find out vector either AC or find out vector BC, whichever vector you want to find out. Take the cross product of these two. So I'm taking AB. Vector AB is going to be -1, -3, and 1. Vector BC is going to be 1, 0, 1, 1, 0. That you get by AB is OB minus OA. AC, if you want to find out, it's going to be OC minus OA. If you want to find out BC, it's going to be OC minus OB. So that's how I get this. Now, my area formula is this. So if I want to find out the area of the triangle, this is what I'm going to use. So half AB cross BC, or you could take out here AC as well. That's fine, up to you. So AB cross BC, you find out the cross product, and that's your cross product. It's explained earlier how do you find out, so not wasting time on it. And just take the magnitude of this, and don't forget to divide by 2. So that's your answer. √6/2 is the area of the triangle. Hope this video helped you to figure out the applications of cross product and its certain properties.